Hey there. So, today we are going to be building a demo for the flood fill algorithm. Building these little demos on CodePen, so we need to make a new pen. And right now that just means a lot of copy and paste. Taking my last script about the midpoint ellipse algorithm and cloning that. And the actual demo code I keep at the top in this game logic section. I'm going to move the ellipse part down a bit. Yeah, down here with library functions, just above draw circle. And we don't want to be animating this anymore. Let's see. For flood fill, need to just have something interesting to fill. So I'm thinking we'll have an ellipse and we will draw a square over that. I think I had a function for that. Let's find out. If we don't have one, we need to write one. We can draw a line. We can set pixels. Get pixels. Got horizontal and vertical lines. Draw a rectangle. That's what I want. X1, Y1, X2, Y2 color. Because for a flood fill, we need a weird shape that we can demo it with. Let's see. Make it a little bit wider. And a lot taller. Too much. So we're going to see if we can shade in this weird section here in the middle. So let's see how we're going to implement this. And I'm going to refer to this flood fill algorithm description on the Geeks for Geeks website. The flood fill algorithm, I've implemented it before, but it's a lot like the A-star pathfinding algorithm. Basically, you start from a position and you just start walking around until you have your code walk around, checking any unchecked spots until you hit the boundary color. Let's see. It has a JavaScript implementation here. Let's see if we can use that for what we're trying to do. Function returns if the given pixel is valid. I'm guessing previous color. No, I don't want to guess. How do you use this thing? current color. So it converts the current color to a new color. Shouldn't need to do that. Maybe this code doesn't have a way of getting the current pixel. So we create a queue of all the points that still need to be checked. And we keep going as long as there's something in the queue. I think we'll be able to mostly convert this as is. Yeah, as a professional computer programmer, I can tell you that the proper way to implement most any algorithm is to go look it up. So what is M and N? I think that might be the width and height. Flood fill, screen, MN, XY. Let's see. Yeah, rows and columns. That makes sense. M is the height. Alright, we can get this thing converted. So we're going to do it like this. What did I call my width variable? Just width. How was I annotating the colors? Yeah, just like that. I'll pretty this up a little bit more when I convert it into TypeScript later today. And this can technically be inverted, and then we would be able to simplify that block a bit more. Basically, this needs to be in range. And then we don't even need that bit anymore. We can just do like this. There you go. Pretty little one-liner. So once again, we don't need screen. same. Let's see if we can just get this thing running, and then we'll work the code a little bit. See if we can make it just look a little nicer. Anytime it's writing the screen, we replace that with a set pixel call. We're almost at the bottom. So what it's doing, we make sure that the current point is valid, like it's on the screen, and it matches the color we're trying to replace. Flood fill, I am actually going to take away the previous color parameter and replace it with this. We're going to replace whatever color was at the position we're writing to. So in this case, if we are flood filling the very center of the screen, it's going to pick up that blue, and it's going to replace all the blue with a new color until it finds a pixel that is not blue. And I'm actually going to stuff this in here. Is valid is only used by flood fill, and then we don't need to pass in previous color because we have it in scope. Now we'll simplify things a little bit. So we set the pixel that we're starting at to the new color, and we push that point onto the queue. And then we sort of have a recursive thing going on, but without actual function recursion. Pop that point off the queue, check the points around it, but we're only checking in the 4 cardinal directions. We're not checking all 8 points that we could be, but that's actually a good thing, because like you can see in this little corner of the ellipse, if we checked all 8 points, then the flood fill would extend past the ellipse. We actually want it to stop there, so we needed to just check like up, down, left, right. But you can change that yourself if you wanted to. But basically, make sure those are valid points. That's the right color, it's in range, and then we change the color, push that point onto the queue with all 4 positions, and then go back and do it again. And we keep going until It's like if isValid was demonstrating that the color didn't match the color we're trying to match on, then it would stop pushing points. So eventually it'll run out of points to queue up. It'll either fill the screen or it'll reach the boundary. So if we do this, flood fill width divided by 2, height divided by 2, and we're going to fill it with a green, which is, that's color index 2, I believe. And I have an error somewhere. Curve pixel is not defined. Right. Now it's defined. And that did not work. Let's find out why. The theory's right. Oh, that's too many parameters there. So that's one thing. Still not doing it though. Let's make sure we know what getPixel is doing. It's near the bottom of our script. There. Taking the x, y, and y coordinates, getting the offset, make sure it's in range, return black if it's not in range. Otherwise, pull out the RGB values from the pixels array. That should be working. We'll log that just to be sure it's doing what we think it's doing. And yeah, that looks right. So we're pushing the current point. I'm going to change these names in case it is getting confused. I wonder if comparing the colors is giving us trouble. Because it's comparing objects, and object references get funny when you're comparing them. RGB. So I'll compare the three components. There we go, that was the problem. So the two color objects were technically the same, but because they were object references, they were not equal. And there you go. We now have a flood fill function. See if there's anything else to clean up here before we wrap up. But yeah, I did end up modifying as we went along. So I think I'm going to leave it at that for a moment. And that is all for now. Thank you for watching, and make sure you like and subscribe to the channel if you want to keep getting these updates. I think on the next video I'm going to be demonstrating how to turn this flood fill function into something like the A-star pathfinding algorithm. We can see, like, compare and contrast the two algorithms. I think it's pretty interesting. So, to be continued.